Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also helps us reach others in need of assistance with these topics. So in today's video, we are going to be looking at calculus-based physics, and we're going to be looking at one-dimensional motion and how to solve equations involving them. And this will be our first part in this series. Now, before we actually get to the problem listed here on the screen, just to let you know that we did make a video that covers the equations, all the equations, and how to solve for them using one-dimensional motion in a previous video, and the link to that video is in the description below, and that is a very, very helpful video to help you with one-dimensional motion using calculus-based physics. So looking at our problem here, we have the velocity of Mike is given according to the following equation, where our velocity of x is equal to 9t squared minus 16t, and it will be in the units of meters per second. So we have to determine the net displacement of Mike from 1 second to 4 seconds. And we also have to find the acceleration of Mike at 4 seconds. All right, so working with the first one, our net displacement, we will label as delta x. And the net displacement will be our definite integral of the velocity over time. So we will have our initial time given to our final time given for our velocity equation dt. So just plugging in what we have, our initial time, which was 1 second, our final time, which is 4 seconds, and then we're just going to plug in the velocity equation we were given of 9t squared minus off 16t, and that will be with dt then. So not a very difficult integration process here. 9t squared will just be 9 divided by 3 times t squared, which will give us 3t cubed. And then we would have 16t, which becomes 16 times a half t squared. So this will just be 8t squared. And then we will have that from 1 to 4. Alrighty, so let's go ahead and evaluate this integration from 1 to 4, this value from 1 to 4. So we will have 3 times 4 cubed, subtracting off 8 times 4 squared. And then subtracting off 3 times 1 cubed, subtracting off 8 times 1 squared. And we end up with 64 minus a negative 5. And you have to be careful with the minus sign. That's an easy thing to miss. And so we end up with 69 meters as our net displacement of Mike when he is traveling from 1 to 4 seconds. Alrighty, so that's our first one. And then our second one here, we have to find the acceleration of Mike at 4 seconds. So the acceleration, which will be a sub x, is the first derivative of the velocity with respect to time. So what this means is that a sub x is equal to dvx dt. So we would have our derivative with respect to t of our velocity equation of 9t squared minus off 16t. So easy derivative here. So we would have 9t squared will become 18t, and then 16t just becomes a minus 16 there. So now we just have to plug in t equal to 4 seconds because that's where we are told we have to evaluate it at. So our acceleration at this time becomes 18 times 4 minus off 16, which gives us 56 meters per second squared as our acceleration at 4 seconds. Keeping in mind that the units from the first one of meters and the meters per second squared were based upon our starting units of our velocity equations of meters per second. So our displacement will always be in a distance, acceleration will be distance over that time squared, and velocity will always be distance over the time. And that's how you would solve that particular problem, determining the net displacement and acceleration if you are given velocity. So I hope this video was helpful, and if you want to see more problem solving this Friday, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all that does help us out. Thank you for watching, and I hope you have a fantastic day.